Any questions on this? For anybody sitting in chat. I know I got a few people in here. Maybe there's some rando from Nantucket watching me right now. Stalking me right now. Eating lots of bagels right now. Everybody's just doing stuff. Okay. If that was the E1 problem, let's talk about everybody's favorite topic, graphing. Whoosh. Okay. This is the Unit 2 graphing problem, or problems rather. I'm going to leave the C3 and C4 problems to you. Those are the problems where you're looking at either a position or a velocity graph, and looking at it, for the position graph, you're looking at the slope to detail how the object is moving, and for the velocity graph, you're looking at physically where it's reading on the y-axis. So those are the problems where, for the velocity at least, is it variable or constant, curved or straight, and then is it moving closer to the x-axis, time axis, or is it moving away from the time axis? For the position graph, you're just looking at slope there and telling me what the slope does. We have a good handout and worksheet that we did in class regarding those type of problems. Highly recommend you look that over to get some help with it. And we also did a number of skirmishes at the beginning of the class days that have that kind of information on it. So if you need to look back at those skirmishes, I can reopen those up in the next day or so that everybody can look at it. Okay. The problem people really had with graphing was the E3 problem. This is what I refer to as counting. That's it. It's just counting. If you can count, you can do this problem. Allow me to sketch a quick graph here where this is our time axis and this is our position axis. So this is a position time graph here. Okay, so what we're looking to do here is on the E3 problem, we are looking to find the distance an object has traveled, and we are looking to find the displacement the object has traveled as well. Okay, I'm just going to construct a quick little graph. Whoosh, 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 whoosh. Okay, cool. And let's just call this 1, 2, and then we'll just call this -1 and then -2, where the very bottom here is tagged up to -2, as we can very well see. Okay. If I wanted to find the distance on this graph, and let's take this from the time period of 0. So let's go from a time period of 0 through, I don't know what this is out here. Let's just call it 8 seconds. Okay. It honestly doesn't matter. I don't even care what I number this. Name it 82. That's not a number. And name it 17. Whatever. It doesn't matter. What I really care about here is counting. If I start counting up and down, if I start at the beginning, notice even though this is going through some time to the right, I don't care. The only thing I know is I'm starting at this point, I'm finishing at this point, and I want to know how many ups and downs I've gone through, because my ups and downs are actually how many steps left and right I have taken. If you took this graph and just kind of spun it, you would see it would kind of look a little different in terms of it looks more like a number line then. Our number line is just sitting up and down. So if I look at this going from here to here, in order to go from the base of where x equals 0 up to x equals 2, I had to go up 1, 2. I didn't change my position as I went through this time. I'm still at 2. Then when I came back down, I came down to 3, 4, 5, 6. I didn't change anything here. I'm still at 6 because I didn't go up or down. Then going back up, I went 7, 8. I didn't change anything. coming down, I go 9, 10, and I didn't change anything. So looking at every single step up and down I took here, I went 10 meters. Okay? This is every step. Every single step, up and down. But you don't care about left and right, because you could be at a position and you could just sit on your butt there for days and then move up and down again. Okay? So it's only the up and downs you care about in this problem. For this displacement, what you care about is even easier to figure out. It is your final position minus your initial position. Okay? When we look at our final position minus our initial position, well, our final position here, if I go read it across to the x-axis, my final position is -2 minus my initial position is 0. -2 minus 0 is -2. Boom. Boom. I'm done. This is a counting problem and then subtracting two numbers for a displacement. A ton of people miss that. Very, very sad. I cried myself to sleep that night, but I guess it's a part of the job. Okay? That was the E3 counting problem of Unit 2. Any questions regarding this? Looking at that, how to do that type of problem?